There you go.
All right, everything look good?
Yep.
Awesome. Hi, everybody. My name is Selcuk. I am a software engineer on AWS AppMesh. I am joined by Apurup Chevuru, who is a software engineer on Amazon Elastic Kubernetes service, the networking team. He's one of the core maintainers of the AppMesh controller for Kubernetes. Today, we're going to talk to you about the service, our recent mutual TLS feature release, along with the SPIRE integration that Omar mentioned. Interesting. Left and right's not working. That's interesting. Okay, give me 1 second. It looks like the slideshow broke. Classic. There we go. All right. So I'm going to go over a very brief introduction to AppMesh, and then even more brief talk about mutual TLS authentication. And then I'll be talking about my observations of when I was evaluating SPIRE to use in the container services. And it's really interesting that we just had the presentation before this, and it'll be clear as to why at the end of my section. That I'll be handing it off to Apurup to talk about the integration with the Kubernetes controller, as well as the SPIRE examples. And then we'll have a section for Q&A at the end. Please do save your questions for that Q&A section, just to make sure we can get through all the content. So what is AppMesh? It's a managed service mesh. There's a lot of definitions for what a service mesh is. The one that I tend to go with is it's a mechanism for providing centralized, consistent controls and observability as your organization scales out its use of services. So here's kind of a nice little kind of marketing picture of how it might fit into your architecture, where you have some internet traffic coming in. It comes in through some sort of an ingress gateway, and your traffic stays within the mesh between your services with encrypted communications. And then the mesh is responsible for exporting a bunch of telemetry and observability data into various monitoring tools. And you can use the mesh to dynamically change let's say the topology of your service communication, the routing and such. The way that we accomplish the service mesh is by leveraging the Envoy proxy, which is a CNCF graduate open source proxy. It sits in front of the application, and you come to AppMesh through our APIs. You define what your mesh looks like. We transform that into Envoy configuration, and then we have a Envoy management service that implements Envoy's XDS protocol, which allows it to configure its clusters and its listeners and a whole bunch of other things. And then Envoy, as it connects to EMS, Envoy Management Service, it maintains a persistent connection, and AppMesh pushes configuration to Envoy as the mesh configuration changes. All of the communication within a mesh happens typically between Envoy proxies, although you could technically have an Envoy speaking to some external endpoint or an application directly if you're migrating, for example. And in this case, you can kind of see a very sort of a bespoke example just to highlight that you can have, for example, a pointer to a file system for your TLS materials. And then what we're also introducing as part of this release is supports for a secrets discovery service provider. So that's, again, one of those XDS protocols. And in this case, of course, that's SPIRE, the SPIRE agent. As long as you install it alongside your proxy and you set up the Unix socket connection there, Envoy will reach out to the SDS provider and ask for a secret name based off of what you've configured for the node that Envoy belongs to. So it would probably be a SPIFFE ID, right? So that's what you would, and the SPIFFE ID would be something related to the mesh domain, and then maybe in our case we have these constructs like virtual nodes, maybe a virtual node name. And Apurup will talk to you more practically about like the implementation and what it looks like to configure one of these items. Again, I'll talk very briefly about mutual TLS because I suspect it's a pretty familiar topic to the crowd here. It's an optional extension to TLS, where the client also provides a certificate, and the server validates it based off of some criteria in the same way that a client might validate the server certificate. Because a server could now Because the server is now deciding how to validate a client, it also provides sort of a soft or a light authorization mechanism, which is enough for some environments where they don't necessarily need fine-grained authorization controls yet. As organizations are scaling out their services, minimal implicit trust is really important, even if you trust the surrounding environment that the services are running in. And so customers reach for mutual TLS fairly often. It's one of our most, it was one of our most highly requested features. It's a fairly scalable solution because we have a lot of experience building out, X509 certificate management, and it's fairly ubiquitous. If you have a reasonably modern service, it's probably going to have TLS and MTLS support. Some types of compliance require mutual TLS. And so customers are either reaching for it because it works very well for their use case or because they have to for some sort of a compliance or regulatory policy. So when we looked at in the industry last year, we saw SPIFFE and SPIRE coming up a bunch, and it's supported, it's battle tested, it's something that we felt confident and comfortable recommending to our customers, guiding them towards it and building some sort of a integration with that Apurup will show you in a little bit. Now, our customers use us on several different platforms, primarily these ones. So Amazon ECS, Elastic Container Service, where you have a fleet of EC2 instances, and ECS will orchestrate your containers across your own fleet. So you still maintain control of the instances. There's AWS Fargate, which is a flavor of that where Amazon manages the instances as well. So all you say is, here are my containers, run them for me. There is Amazon EKS, so Elastic Kubernetes Service, and then plain Kubernetes are where you can run AppMesh, or typically are running AppMesh today. So Apurup is going to be talking to you about those asterisks and how we supported that with our controller. I'm going to give you kind of a different view of why we weren't able to bring SPIRE immediately to ECS and Fargate customers. And then I'll talk to you a little bit later about what that means. So if we take a step back and look at EC2, the SPIRE design is beautiful and it works really well on that kind of an environment. The agent uses this thing called an instance identity document from the instance metadata service that's available on every EC2 instance. It's cryptographically verifiable. That document is verified by the SPIRE server for node attestation. And then the agent can use regular OS primitives for workload attestation as it would in a lot of environments. So that all works really well. If we take a step forward and we look at ECS, this is now those lighter colored boxes are representing kind of the units of deployment in ECS. So a task is, if you're familiar with pods in Kubernetes, it's kind of just a collection of related containers that are deployed together. And then a daemon service is just a task that happens to be deployed, in every one of the nodes that you select. It's your instance still, so you can do what you need to in that environment to solve your business case. But ideally, you're still not breaking out of the container task boundary to, for example, interrogate the Docker daemon or to find information about the underlying environment. And you're unable to mount sockets between a task and a daemon service today. So this architecture is, as far as I could tell, not quite possible today anyway. So maybe you change your design and you have something like this, right? Where you have a SPIRE agent that's co-located with every envoy. You're using the instance metadata service still, and then the task metadata, which provides credentials to each task, right? So you don't necessarily need to solve that credential zero problem. The problem here is, of course, that the IID, the instance identity document, no longer uniquely identifies the node because now you have multiple agents running on it. And the task metadata doesn't have the equivalent of this verifiable task identity, at least not today. If you take another step further and you look at Fargate, where you don't have the instance at all, this is all you can really do, right? You have the task metadata, and you have the information that provides to you, and then you have your containers that are co-located together. There's no daemon services, so this is what you're trying to accomplish. So that starts to raise some questions. How does workload attestation work without the primitives that we're used to, like talking to the Docker agent or kubelet or the OS? And in AWS, like I mentioned, the credentials are bootstrapped, but we don't have that managed option for node attestation. There is an API called Get Caller Identity in the security token service where you can say, here are my AWS credentials, tell me who I am. And it does work, but there are caveats, some of which I've laid out in, I think, the GitHub issue regarding this serverless support. I had mentioned that several months back. How does workload registration work in that environment? You need something analogous to the Kubernetes registrar to make sure things are happening in the right order. This is probably the most easily solvable problem, but it does require something either within the SPIRE environment or within ECS to make sure that those registrations are happening in the right order. And then, of course, does one-to-one agent to workload make sense? I know this question is kind of ironic given some of the conversations that we had in the last presentation, but I don't have the answers to these questions today. I had a really good conversation with Evan and Andrew from the maintainer team several months back. They were able to explain to me the problems that SPIRE was solving and the design decisions there, and I was able to give them the perspective that I was seeing of, we're evaluating it for ECS and Fargate, and here's what we're running into. So that was really valuable, and thank you to them again. I'll leave these questions here, and we'll see, and it's really interesting to see the serverless support coming in, because I'm sure that there's something there that we can accomplish. If you have any ideas, if you've solved this problem, or if there's something that I've misattributed or missed, please let me know, because we really want to bring SPIRE to our ECS and Fargate customers as soon as possible. But I'm sure that there's going to be some work required either on the AWS side or on the SPIRE side or both. Now, I know it's a bit abrupt. I'm going to hand it off to Apurup, and he's going to talk to you about our Kubernetes integration.
Hey guys, so let me share my screen. Can you?
There you
go. Okay, awesome. So can you see my screen?
The terminal.
How about now?
We see the terminal.
Oh, okay. We don't want the terminal. Let me pause share, new share, PowerPoint, share. How about now?
No dice.
Nothing?
Yeah, still the terminal.
Just bring it in not full screen mode. Yeah. Just close the animations.
You see the PowerPoint right now, or you still see the terminals?
Yeah, we see the PowerPoint now.
Awesome. Okay, so hi everyone. So I'm Apurup. I'm part of the EKS networking team. I work on the Kubernetes AppMesh Controller. I'm one of the maintainers of the controller's GitHub repo. So if I provided a good overview of the SPIRE and MTLS integration at the service level, I'll focus more on SPIRE integration with AppMesh workloads on a Kubernetes cluster. This is how I structured my quick talk. I'll start off with a quick and brief introduction of the EKS and AppMesh integration and the role the controller plays in it. I'll move on to SPIRE integration, and I'll share our initial experience scaling up SPIRE-enabled AppMesh workloads on Kubernetes clusters, and what we are looking at in the near future in terms of SPIRE integration, and if time permits, a demo and Q&A. So the goal of the AppMesh integration with EKS is to mainly provide a Kubernetes native way to create AppMesh resources directly on the Kubernetes cluster. And we do that with good old CRDs. We have a CRD for every upstream AppMesh resource. A controller is running on the Kubernetes cluster that is trying to reconcile these resources. So for those of you who work closely with Kubernetes, controller is probably a very familiar concept, right? So it's nothing but a control loop, a forever running control loop that is trying to watch on a particular resource and reconcile it to its desired state. And AppMesh controller is a collection of such controllers, with each controller watching a particular AppMesh resource and reconciling it with upstream AppMesh service. And it does some dependency resolution with the help of some validating and mutating webhooks. In addition to that, controller also sets up the data the data plane for the AppMesh workloads on the Kubernetes cluster. So Envoy is the one that's doing the heavy lifting in the data plane. And whenever the controller comes across a pod that's part of an AppMesh workload, it injects Envoy into the pod spec with the help of a mutating webhook. And it provides these envoys with some identity. So when they come up and talk to the AppMesh control plane, they can identify themselves saying, hey, I belong to so-and-so virtual node. So the control plane knows, what config to when to these envoys, right? I'll come back here when I'm talking about SPIRE integration, but with that quick introduction out of the way, I'll move on to SPIRE integration. To begin with, I'll start with some basic assumptions that with respect to SPIRE deployments, users are responsible to manage their SPIRE deployments. They get to choose the SPIRE deployment model that best fits their use case, depending on the scale or, whether all their AppMesh workloads are confined to a single cluster or they're spread across multiple clusters. So from the AppMesh point of view, we expect a node local SPIRE agent to be present, which essentially means that SPIRE agent needs to run as a daemon set in the Kubernetes cluster. And the SPIRE agent's UDS path needs to be passed to the controller. So the controller knows how to set the envoy up, right? And if I go back a little, whenever the controller comes across a pod that, that's part of a mesh workload, and if it finds that STS is enabled for this particular mesh workload, the controller will inject or mount the SPIRE agent's UDS socket into the respective envoys, right? And once that's done, Envoy will bootstrap a static STS cluster into its config, right? Right now, the workload and node registration process is out of the controller, meaning the users will have to manage it. But we do have some near-term plans to integrate it natively with the controller. I'll talk about it in the what's next section. However, we do vend out some sample reference Helm charts to install a SPIRE agent or a SPIRE server. So that's one of the common requests we get. So whenever we release an integration, we usually get asked, hey, do you have some sample Helm charts with which I can get started with? So we have some sample Helm charts that we publish in the EKS charts GitHub repo with bunch of configurable parameters. So customers can set their own trust domain, default TTL, SVTTL values, et cetera, and they're free to modify, enhance, and tailor it to their particular use cases, right? So this is how a sample STS config looks like. On the left-hand side is a sample STS enable MTLS config for virtual node. You have a certificate section that's referring to the app's SPIFFE domain. You have a trust, the validation section with both the CSRT and the SANS referring to the backends. And on the right-hand side is a sample STS cluster that Envoy gets, the Envoy bootstraps with. So this is what I was talking about with a SPIRE agent running on every node, and the envoys running on that particular node will reach out to the local SPIRE agent to source their certs, right? So I'll share some our initial experience with scaling up SPIRE enabled AppMesh workloads. So a quick caveat here is that we didn't really iterate through different deployment models to see what best fits the scale that we are trying to test on the Kubernetes cluster. The goal is also to test the AWS side of the stack to see if the controller can handle it, the service can handle it. So we've started off with a very base deployment. We tuned some resources, right? So with that caveat in. So this is the deployment model that we started off with. It's a base single cluster deployment model that we, the server as a stateful set, agent as a daemon set. It's a 500 node cluster. So we have about 500 agents, right? It's not a massive scale. We scaled up to 10K envoys in a single cluster. And we scaled, with respect to unique workloads, we approached almost 1,000, right? And most of our testing was done with the version 0.10.0 with some testing with 0.11.0. And these are, and what we see is when the number of unique workloads are relatively low, let's say around 250, let's say we have 250 workloads with 40 replicas of every workload, almost all the 10K envoys were immediately able to source the certs, and the entire MTLS end-to-end traffic verification worked as expected, right? But as we try to scale the number of unique workloads, we see delay of approaching 3 to 8 minutes depending on, by the time all the envoys could source the search from the local SPIRE agent, right? And as we scale up the SPIRE server and agent resources, the delay trended downwards towards 3 to 4 minute mark, but that is something that we still observed in our tests, right? So we do plan to experiment with tuning the resources, on both the server and the agent side, and horizontally scaling SPIRE for instance as well, and see how it behaves in. So going forward, in the near future, we want to integrate SPIRE natively into the AppMesh controller. Essentially, we want the controller to take over the responsibility of the Kubernetes workload registrar, right? So the cluster might have some resources that are part of the mesh. Some might be normal pods. So the controller has visibility on which pods belong to the mesh, and so it has context on what workloads need to be registered with SPIFFE, right? So, and we want to integrate it with the controller, natively. And there was a talk earlier in the session about serverless, so that's a big use case for us as well, trying to get SPIRE running on EKS plus Fargate. So we have a sample walkthrough that we published in our GitHub repo with it's an AppMesh MTLS workload with SPIRE as the SDS provider. If I'm not sure how I'm doing on time, if I can walk through it quickly. Or how can I take over and share it? Do I have?
Yeah, absolutely. Take a few more minutes for sure. And if anybody has any questions, please put them in the chat window. So while we collect the questions, maybe you can do a quick walkthrough.
Sure. Let me share screen. Okay, so hopefully you see my terminals. Do you see my terminals?
Yes.
Okay, awesome. Okay, so I did, in the interest of time, I did set up the entire AppMesh workload to save some time. So I have
I don't see anything moving on your screen. I'm not sure if it's supposed to.
I'm typing something. Do you see anything, or you just see a static image?
Static image.
That's not good. Let me pause it and resume the share. How about now? Anything?
We see your mouse, but I don't see anything typing. Like it's already typed there. I don't know if anyone else sees this. You're seeing it?
No. Do you have multiple terminal windows open, Apurup? Because it doesn't look as selected.
I have two side by side. You don't see anything you're seeing.
Maybe
just the terminal.
I can stop share and try reshare. Let me share the desktop completely. So how about now?
There you go.
Yep.
Okay, you see. Okay, so I have a sample AppMesh set up on the Kubernetes cluster. I have a bunch of deployments behind those AppMesh virtual nodes. All the virtual nodes are enabled with MTLS. So I'll quickly show you and the individual deployments will be able to source the certs. Where is that? So we have one front-end deployment and a bunch of back-end deployments, right? So the front talks to the three color deployments in the back-end via virtual nodes, and we have MTLS configured between these services. So in the current state, there is no workload registration entry for green. So the green pod is not able to source any certs from the local SPIRE agent, whereas the blue pod is able to get the required cert. We have both the CS cert, which is our trust domain, and the corresponding app cert as well, right? And if I can quickly show how the whole thing works with, so if I'll bring up a sample curler pod. And if I make a sample call to the front, the front deployment, and it's doing a header-based redirection. So if the color header has blue in it, it will make a call to the blue pod. If it has green, it make a call to green pod, and so on, right? So we can see that we get a response back, and I can see that if I show you the SL handshake, we'll see a brand new handshake happening. Oh, it's using the same. It's using the same. Yeah, it's using the same session. Anyways, so right. And if sorry, copying and pasting the wrong commands. So when the front tries to talk to the green app, since the green doesn't have any certs, the communication essentially fails. So that the reason behind that is we didn't register any workload entries with the SPIRE server for the green pod, so it's not able to source any certs. So the MTLS communication between the front pod and the green pod, will not work as expected. So the walkthrough itself is rather detailed. So if you're interested, you can follow it, and I'm on the SPIFFE channel, and you can ping me. Yeah.
No, thank you so much, guys, for this. Any questions for the AppMesh team?
Yeah, I had a few questions.
Absolutely, go for it, Adam.
Yeah, so whenever in your example, like front talks to blue or green, what host name is it using to talk to it, or how does Envoy, I guess, expose that external service to the front end?
Can you come again? So you're talking about when the front talks to the blue or green?
Yeah, what host name does it use to talk to them? Is it host-based routing, or is it like assigning in a port?
It's a host-based routing. It uses the host name, which is the blue dot. So if it has a corresponding service in the Kubernetes cluster, which is blue dot the namespace dot server service dot cluster dot local, right? And the Envoy will then forward it to. So the Envoy config will have an endpoint to that particular, blue pod. So the request will land on the Envoy, which is sitting next to the blue pod, right? And when I was sharing that virtual node config, we have a sans section there. What are the subject alternating names that we expect in the SWIT? So we include the blue pods SWIT in the front pods, the SAN list in the backend list, so that the cert verification will work as expected.
Okay.
The hosting will work as expected. Yeah.
So the actual application can use the host name. It's not just Envoy pointing at the service.
That's right. Yeah.
Okay. And then the other question I had was this support federation use cases. Like I noticed the virtual node config. Right now we're using Envoy to allow external trust domains as well.
I mean, it should, right? So right now, the entire SPIRE deployment is completely in users' hands, right? So we are not managing the SPIRE deployments for them. So if they do have use cases across multiple trust domains, then I don't see a reason why it won't work. So we did test federation, but not at scale. It worked as expected for us. We basically tried to federate multiple trust domains in 2 different EKS clusters. So a service in one mesh trying to talk to a service in a different mesh, and yeah, it worked as expected actually for us. Yeah.
Okay. And I think the last one was, is there support for I think like external authorization, like open policy agent that we could tie the Envoy deployment into as well?
I guess if I can talk to it, but right now we don't have OPA support yet, but we can probably expand on it.
Yeah, so it's basically what Apurup said. We have a public roadmap. So it's AWS AppMesh roadmap on GitHub. We have a bunch of issues there, including a feature request for open policy agent. I don't know what the timeline is on there, but feel free to, or please do make some noise +1 that and give us your use case, because that can help us kind of prioritize and design around it. And if you want to talk to me directly about your use case, please hit me up on the SPIFFE Slack, because that's one of those high importance. External authorization is kind of a high importance feature for us as well.
Okay, I'll check that out. Thanks.
Great, thank you. Zach, do you have any questions? I don't know if that was answered or not during the presentation.
Yeah, I think it was.
Okay, great. Any other questions for the team?
Yeah, I had one quick question.
Yeah, absolutely.
Yeah, so you were talking a bit about doing some load testing and trying to validate SPIRE at a higher scale. I was curious if you had taken a look yet at the 0.12 release of SPIRE, or if you were just focusing on the 0.10 and 0.11 so far.
Good question, actually. So we started off with 0.10, right? So when we initially started off integration, around September last year, and we sort of stuck to it. There's no reason why. I mean, we will be testing with the version 12 pretty soon, and will update you how it goes. Yeah.
Cool. Yeah, I'd be curious to hear how that goes. We did roll in some pretty significant changes to the agent sync operation, where we introduced an in-memory cache in the server. So that dramatically reduces the database load and should overall improve the throughput and the control plane operations. So
awesome.
Right. So essentially, I mean, bumping up the SPIRE agent's resources to 1 gig itself, I guess, since it's a daemon set, it takes up considerable node resources, right? So yeah, we will try with 0.12 and we'll get back.
Sounds good.
Great, thank you. Anybody else? Going 1, 2, 3. Thank you so much, guys. Both of them are on SPIFFE Slack. If you have any other questions, feel free to reach out. I did want to cover a couple other topics really quickly.
Thanks, folks.
And as most of you might have heard, we are doing our community survey. We do these often. It helps the project maintainers understand the project adoption, where you're struggling, where you need help, and all that kind of stuff. I'll post this URL shortly in the chat section as well for Zoom. But if you haven't taken this survey out, you would help the project teams, the contributors, a lot by filling this out. I think information like this is critical when CNCF judges projects by moving from one stage to the other. So please, take this short survey out if you have not already. And as always, this is the first monthly meetup we had started in a much more organized fashion. So I want to do a quick survey around the feedback, particularly around what topics you would like to hear about from different users, from different maintainers, and so on. So please fill that survey out too. I'll post that shortly here. And do tell us if you're, interested in presenting in the next meetup as well. So the currently planned date is March 16th. I do have a couple of potential talks already, but if you have any other ideas, if you like to take one of those, community intro spots to introduce yourself, it will be great. Once again, thank you so much